I think we're ready to go. So we're looking at 9, and so I'm going to sort of talk about these problems and talk about an approach. I hope you recognize that revolutions per minute is not a good unit for us. So I have two rotation speeds that are not in radians per second. I'm given an angular acceleration of 2 radians per second squared, and I want what angular displacement, see? So right away, I know that I've got to get this out of revolutions per minute. So I have to come up with a conversion, and so I put 1 minute on the top, so it cancels out as 60 seconds. Then I got to get revolutions out of it. Well, 1 revolution is 2 pi radians, okay? And that'll convert that. I'll just use the same thing for this 1 minute. And 2 pi radians is what I want, is a single revolution. And I can convert these to give me my W. 33 times 1 times 2 pi divided by 60. 33 times 1 times 2 pi divided by, and 78 times 1 times 2 pi divided by 60. Now, that gives me my W. And I'll wait for you to provide for me. Everybody do it so I can check me. 3, 2, 8, that's 2 pi divided by 60. Am I right? Is it? We'll make that 3.45, wait, 3.454 radians per second. That's my W. And then we'll do it again, 78 times 1 times 6.28, which is 2 pi, divided by 60. 8 tell me if I'm wrong, 4 radians per second. So what do I have here? I have a WI and a WF, and I have an alpha, and I want a theta. So what it makes me think of is VF squared equals VI squared plus 2AD, but that's not, this is rotation. So it's omega F squared equals omega I squared plus 2 alpha theta. That's the analog. So I got to put my stuff in. What did it start out? It started at 33, which is 3.45. Squared times, and then it's a math problem, right? Square the 0.16, do minus parentheses 3.45 squared, end of it, divide everything by 4, that's 2 times 2. And the answer should be 14 radians. 14 radians right here. All right, I'll get to 10 in a little bit. Did you follow all that? So what's my thinking? I've got 2 things that are in the wrong rotational unit. I convert it with ratios. Then I look at what I've been given, and it reminds me of this linear equation that I have to find the analog of, this guy right here. And I just put the numbers in. You should get 14. Good. You know what you have to do? If you got it on you, did you get it wrong? So do 8.164 squared minus parentheses 3.45 squared and parentheses, and then you divide by. I think I divided it. So can we go on to the next one? So you see the general approach? I'm going to clean this up because I need some room. A record that slows from an angular speed of 45 revolutions per minute. I hope you know right away we've got a problem there that we can fix, certainly. Let's do that. 1 revolution is 2 pi radians. So just like before, 1 minute on the top, so it cancels out. So let's find what that is. So I can have my omega in the right units. So that turns out to be 4.71 radians per second. I've got a good unit. That's my omega. All right, what's going on here? What is the angular acceleration? So I say that alpha equals question mark. I have a angular speed already. I got to do another conversion. Actually, is this the same? Let me see if this is the same. Oh, this is the same. I think I'm doing a whole lot more work than it. Is it the same problem? Are 9 and 10 the same problems, but just faster than this? But nothing else is the same as before. Okay. All right, I got to do another conversion. No, it's 33. Oh, but it's a different problem, it's just, okay. So, oh, I can take oh, you're saying I can take the 30? Good, good. What was it anyway? Great, what is it? Okay, thanks for that. That'll help me out. We had done this before. So 3.454 radians per second is my other omega. So what do I have? I have, I want to, let's get this in a nice, neat place. I want alpha. I have Wi. I have WF, the rotational, and I have T. So I know what to use. It makes me think of VF equals VI plus AT, but this is all rotational. See how I think about this? I say, what is this? What's the analog here? Two V's and A and T. So I know what to do here. I'll just do WF equals WI plus alpha T. And that's, the approach that you'll be using on the homework. I plus alpha T. Let me give myself some room. Clean this up a little bit. So the final is, well, this one's slowing down, isn't it? It ends up, its final is actually smaller. It's 3.454 radians per second. Its initial was 4.71 radians per second plus alpha, which I want to find, times t, which is 3.1. And so, subtract the 4.7 from both sides, divide by the 3.1 that's in front of the alpha. And yeah, I remember this being a negative answer. You just should get this guy right here, negative 0.41 radians per second. Got it? Okay. So now, would you like to do the homework now together? 0.41 radians per second squared, that wasn't bad. So what's our approach? Yeah, negative. Yeah, thank you. Negative, right? What's the angular velocity? Alpha equals question mark. I have two omegas, but they're both in the wrong format, so change it. I have a time. What's the analog? It's VF equals VI plus AT, so I turn it to WF equals WI plus alpha T. Remember, we go from fast and negative angular acceleration.